Have you ever wondered what it takes to break into the world's most secure places? I'm not talking about a bank vault. I'm talking about bunkers buried deep underground, hidden beneath dozens of feet of steel-reinforced concrete. These are the modern-day fortresses, secret lairs designed to withstand almost anything thrown at them. For decades, they were the ultimate defensive structures. But as with any great challenge, humanity has a knack for engineering an equally great solution. In this case, that solution is a bomb so specialized, so powerful, and so unbelievably focused that it changes the entire game. It's a key designed for a lock that was supposed to be unpickable. This isn't just about making a bigger explosion. Oh no, that's the easy part. Anyone can pile up explosives and make a giant fireball. The real trick is delivering that explosive punch to exactly where it needs to go. We're talking about getting past the earth, the rock, and the ridiculously thick concrete armor. It's a problem of physics, engineering, and sheer brute force. How do you punch through a wall that's designed to stop anything? You build a better punch. You build a bunker buster, the ultimate can opener for the world's toughest, most well-hidden cans. The very idea is something straight out of science fiction, isn't it? A projectile that can scream through the sky, hit the ground, and not detonate. Instead, it just keeps going, burrowing through solid material like a demonic mole made of hardened steel. It only goes boom when it reaches its final destination, deep inside the target. This is where the magic and the myth-busting really begins. We're going to peel back the layers, literally and figuratively, to understand the incredible sequence of events that unfolds in the milliseconds after a bunker buster meets its concrete adversary. Alright, let's get down to brass tacks. What is a bunker buster? At its core, a bunker buster, an earth-penetrating weapon, is a bomb built to dig. Think of it less like a grenade and more like a high-speed explosive shovel. Its primary mission isn't a surface fireball, that's conventional bombs. Instead, its goal is to survive the colossal impact with ground or a concrete structure use momentum to tunnel through and only then detonate deep inside the target. Two-stage. First penetration, then annihilation. Built differently. Forget thin aluminum casings. Thick, hardened steel shell. This casing is the hero. Special steel alloys, sometimes inches thick, engineered to withstand impact without shattering. Bomb is long and slender, like a giant dart. Aerodynamic shape equals high velocity for penetration. Narrow profile slices through dense materials, rock, soil, concrete. Now let's talk about what's inside that tough shell. Tip, penetrator case, the solid pointed nose cone. Behind that you have the main event, the high explosive payload. But here's the clever part, the fuse. The fuse is the brain. It's a sophisticated device that can be programmed to detonate after a specific delay. It can sense the deceleration as the bomb travels through different layers of material. Okay, picture the scene. A multi-ton bomb shaped like a giant steel arrow is falling from the sky. It's accelerating, reaching speeds of over 1,000 miles per hour. Its target, a massive slab of reinforced concrete several feet thick. The moment of impact is not an explosion, it is a collision of epic proportions. The instant the hardened steel nose cone touches the concrete, an immense shockwave radiates from the point of contact. This isn't like a gentle tap, it's a cataclysmic transfer of kinetic energy. The bomb's incredible momentum, its sheer mass moving at high velocity, is now focused onto a single, tiny point. The first thing that happens is a process called spalling. The concrete on the surface doesn't just crack, it shatters violently. A cone-shaped crater instantly forms as the outer layer is pulverized and ejected outwards and backwards. Think of it like a super-fast drill bit hitting a tile. You don't just get a neat hole, you get chips and dust flying everywhere. The bunker buster is built for this. Its hardened casing takes the brunt of the initial shock, protecting the sensitive electronics and explosive payload. The bomb doesn't stop, it doesn't even slow down much, it just starts digging. As it pushes deeper, it creates a tunnel through the concrete. This process is incredibly violent. Immense pressure and friction literally liquefy the concrete, a phenomenon called flow. The material behaves like a very dense fluid being pushed aside. Embedded steel rebar designed for tensile strength is snapped like twigs. The bomb makes its own path, vaporizing, melting, shouldering aside anything in its way. Friction heats the casing to scorching temperatures. This entire penetration phase lasts for just a few milliseconds. It's a blink-and-you-miss-it event of pure, unadulterated physics. Design focuses on maintaining structural integrity through the journey. If the casing cracked or the fuse triggered early, the mission would fail. But it holds together. Robust engineering. By the time it clears the final layer, it has burrowed through the protective shell. It is now inside the beast, having breached the wall, and is ready for the second act of its destructive performance. Now we're inside. The bunker buster has successfully punched through the thick concrete ceiling, and is now in the open space of the bunker chamber below. The fuse, that brilliant little brain, has done its job. It has counted the milliseconds since the change in deceleration from concrete to air, and has sent the signal. This is the moment the entire design has been leading up to. The high explosive payload, which has been dormant and protected throughout the violent journey, finally ignites. This is not a surface blast. This is a contained explosion, and that makes it honestly infinitely more devastating to the structure. When the bomb detonates inside the bunker, it unleashes a rapidly expanding bubble of superheated gas. Because it's in an enclosed space, that pressure has nowhere to go. It pushes outwards in all directions with unimaginable force. This creates a massive pressure wave, or shock wave, that slams into the bunker's interior walls, floor, and ceiling. Think of it like a depth charge going off in a submarine. The water contains the blast, directing all its energy onto the hull. Here the bunker itself becomes the container, and the structure is subjected to forces it was never ever designed to handle from the inside. The result is total annihilation.